Okay, so let's break down AGI into two major parts. There is the large language model, LLMs, and there is also the optimal policy. There's no question who's building AGI. There's OpenAI, DeepMind, Anthropic, and thousands of other companies. And I think the top ones are pretty much controlled by big tech. Also, let's not forget about the huge movement on open source, basically sitting on Hugging Face. So there are two systems, System 1 and System 2, that comes from the book Thinking Fast and Slow by Daniel Kahneman, I think that's his name. But let's identify what these are. System 1 today, in today's world, is a large language model, basically. System 2 is the optimal policy. Put these together and you probably can create a primitive version of AGI. It might be missing one or two parts, but ideally these are the main two. Like I mentioned, System 1 is basically a large language model, but System 1 is the fast input-output system. In the real world, it would be like the first thing you think about when you hear the word car. Just for a moment, think about the word car. What do you think? You probably think about everything you've ever thought about. The color, the feel, the design, the make, gasoline you're putting in it, people you're driving with. All those are interconnected. Well, that's kind of like how a language model works. It's the interconnections and concepts and ideas that come to mind when you see something. That is indeed the large language model. You have been trained to know exactly what a car is or how to turn on a TV. The process in that. A large language model is deterministic. It makes sense because System 1 is deterministic. But in System 2, that is not true. System 2 is not deterministic. System 2 might use a higher level called optimal policy. One example is how you start a business. Most people have no idea how to start a business. And if some do, they may not know the optimal policy. This idea is what is called Q states. Say in your life, there were over 10 million states or actions. For example, eating dinner, watching TV, taking a test, spending time with family, taking a shower, etc. Basically, these are all state actions. But once your goals change, then your states begin to start changing, moving towards these goals, which if you have enough states in the system, you know what it takes to get to that goal set. Basically, another example is, say you have a plan today to go out and you meet up with Mike for lunch. You made sure you had gas in your car, you had money in your wallet, you made sure you got your work done in time to make this event at noon. You had to map this out in the morning because you gotta make sure everything works. It was your optimal policy. Then the school calls and says your kid needs to get picked up. Now your state changes. Your state that you had in mind from your optimal policy now changes. You have to incorporate the fact that you have to pick up your kid. You say to yourself, okay, you have to quickly update your optimal policy to achieve your goal of still having lunch with Mike if it's still possible. But optimal policy has a larger implication when used in AGI because it's not limited to the conditions we think about individually. The AI could have billions or trillions of states, far more than any group of people would have. The AI will have metastates that humans don't even think about. Given that OpenAI is working on synthetic data with GPT-4, it's highly possible they can create far more states than that even exist in the current world. For example, there was speculation that OpenAI broke this AES 196 encryption because they were able to build a policy to figure out how to derive the decoding, basically to decode the hash without using a key. It was able to train using reinforcement learning to figure out the policy, the process, basically, of how to decode ASE 196. This is absolutely bonkers. And it's also scary because it can impact entire economies of financials and systems and being able to break into things that we typically don't want to happen. How does this all work together in one system? Well, it needs to train on all of the world's knowledge. Like a child that soaks up its environment for several years, once this LLM, the large language model, is trained enough, its higher order optimal policy uses that knowledge to look over every possible state in the system and computes the most likely path to reach the goal. So if you give it a goal, it will basically try to figure out the optimal policy, the process, automatically every individual piece to get to that goal, basically in ways that we probably have never thought about before. So I'll give an example of this. For example, when you did math in grade school, you might have stumbled into the right answer. Most of the time you got it wrong, but you might stumble wrong into the right answer. It might have been better if you did it a certain way to always get the right answer. And that is the optimal policy. You get trained on that over and over again through reinforcement learning through your teacher. Well, this is the same thing through AI. Is an optimal policy that helps you get to the right answer, even if you don't know the answer. But if you know the process, you'll get there. So at the end, it's the process, or in other words, the policy. I'll see you in the next one.